So this is how we are going to find the internal resistance of the cell. The second part, that is comparison of EMF of two cells, is again very easy. So what we have done in finding the internal resistance, let us revise that first. So we had to find internal resistance of this cell, that is this particular uh, cell. We had to find internal resistance of this cell. So in order to do that, we connected a resistance in parallel with that, that is R dash, and then we had a key here. So this key can be open or closed. When this key is open, key comes into picture. When key is closed, R dash also comes into picture. So that's why now the potential difference comes into picture. So for both case 1 and case 2, that is when key is open and this key is closed, we get the two different balancing lengths, that is L1 and L2. And we use, so this balancing length will be actually balanced by this E, that is EMF in the first case and potential in the second case, right? And this is the relation between EMF and potential and internal resistance which we are going to use, that is E minus V is equals to IR. This is what we are going to use here. So this is what we have used here. R is equals to E minus V divided by I from the same relation, and I is equals to V by R dash, this one. So this we applied here, and this we applied these two. From these two we have got this, and so that is E minus V by V, or that can be written as E by V minus 1 into R dash. And now we write it in form of, I mean, the equations which the balancing lengths and the potential which we have seen here, right? So we apply this, that is V is equals to XL2, so substituting that, and E is equals to XN1, so we did these two substitutions, and then we have this final relation, that is relation between unknown resistance R, L1, L2, and the resistance box which we are using here. Now this is what, or this is how we are going to use, we are going to find out the internal resistance of the cell. Next thing is comparison of EMFs of the two cells. Now this is very easy. In this case, as you can see the circuit diagram, and there is a two-way switch here. This switch we use, which you see here, that is a two-way switch. What does it do? In once, as you can see here, it will connect the E1 with the circuit. In the second part, it will connect the E2 with the circuit. So these are the two cells, that is E1 and E2, which we want to compare, right? And in both, in this, what will happen, when one will be connected, you will get a balancing length. When two will be connected, you will get another balancing length. So respectively, we'll have, say, for example, E1 will be balanced at length L1. So let us call that E is equals to XL1. E2 will be balanced by, say, some other length L2. So let that be X into L2. Now from this, I have this comparison ready for me, that is E1 by E2 is equals to L1 by L2. L1 divided by L2. That's all. This is how we are going to compare. So in lab, what we are going to do is, we are going to find one length for E1, keeping E1 in the circuit, then change that switch to connect E2 in the circuit, find L2, and from that you will get the, so out of these four things, L1 and L2 we are going to experimentally find. Out of E1 and E2 you will have one of the values, so that other unknown can be found, or you can simply have the ratio of E1 and E2, that is in which proportion or what is the ratio of E1 and E2, we will be able to get that. Right, so that's what, or that's how, these are the applications of potentiometer.